Hello everyone, welcome back to SAT Math Question of the Day. Let's start with the question. Which of the following represents the graph of x equals negative 1/3 y? So we'll have to just scroll down, otherwise the screen gets too small. That's probably good enough. And let me...
Wait, are there 5 choices or 4?
No, only 4.
Okay, got it.
There we go. Okay, so that's good enough. That shows it good enough. I mean... Now, notice that this is normal. The xy coordinate is normal. So you really want to solve for y. Y is a function of x. So let's solve for negative 3x is equal to... 3x is equal to negative y. 3x, so y is equal to negative 3x. Y is equal to negative 3x. So the slope, as Seth said... Well, Seth actually got it wrong. Oh, my God. The slope is negative 3. So you've got a negative slope. Goodbye. Oh, these are all negative. And then you got a slope of 3, which is pretty steep. So then you just confirm that it's this one. This looks like it's a slope of 3. This is a slope of 3. But this is y is equal to negative 3x minus 3. And this equation is y, the proper equation is y is equal to negative 3x plus 0. So it goes to 0. Right. Well, this is just classic, just not understanding how to graph a linear equation, but you've got to get it in the form y is equal to mx plus b. So important. I'll overdo it here. Y is equal to mx plus b. So important when you're graphing linear equations. You've got to get it in this form. Because this is... I mean, this is more the mechanical approach. We're not really explaining the big concepts behind this. At some point, you just have to know this rather than understand the deep concepts behind this, because you can go crazy understanding the deep concepts behind it. The bottom line is you just have to know that when you graph a linear equation, you fit it in the form y equals mx plus b. M is the slope, and b is the y-intercept.
Okay. Let's scroll back to the original question. So I want to call our audience attention to the thing to watch out for in this problem.
Yeah, and I need to erase some stuff so that you can talk. So I'm just going to erase all this stuff I wrote.
Yeah. I'll show you the blunder that I made when I was overconfident about this problem.
Yeah.
Okay. Here's the blunder. They give the equation, right?
Yeah.
And the thing you need to watch out for is that the equation is written in a sort of an opposite form.
Yeah.
From what people and that describes the slope. It's an opposite form from Joel said mx plus b. The x is written as the dependent variable.
Yep.
On the left, and the y, the problem is the trick of this problem is that the y is the independent y, not x,
right,
is the independent variable.
Yeah.
Okay. And so you have to then realize that this is not in the, it's not in the form y equals slope.
Right.
times x form.
Right. So,
but now when you have an equation that's in the opposite form, x is equal to, let's not call it m, let's call it t, but tricky. Then we're assuming t is not 0. This is equivalent to y equals 1 over t.
That's right. You solve for
times
y.
X.
You just solve for y. You solve for y. You always solve for
Yeah,
y. You
yeah,
always solve
yeah.
for y.
So the truth is, my blunder was that I saw this, and my mind made the mistake of pattern matching it against
Right.
What I expected, which is y equals mx, where m is there in that form. M would be the slope.
Right. So basically, you misread the problem because you're so familiar with that form. We always do that in life, right? You look at something in the world and you see it through the lens that you're used to seeing it, and you're not looking at exactly what's going on. We make this mistake in society all the time. The thing is, the other mistake you may have made, Seth, is maybe you didn't say to yourself, subconsciously or consciously, this is too easy of a problem. Come on. Would they really ask a question? Would they really ask a question, particularly in the advanced side? Now, you don't know when you're taking the test whether it's advanced or not. But would they really ask a question this easy? And would they really say, oh, here's the graph. Y is equal to negative 1/3 x. What's the graph? No, they probably wouldn't ask a question that easy. So that should be a tip-off that you're missing something. If you're doing the test and the question is too easy, like ridiculously easy, really easy, question yourself and say, maybe I'm missing something. But sometimes they actually do throw in a question that really is easy. So you don't know. Sometimes there's usually 1 or 2 questions that you really can answer in 1 or 2 seconds. That really are legitimately easy questions. But
do they always present you the questions in order of difficulty?
You would think they would, but I don't know.
Well, your experience with seeing sample tests.
I would say yeah.
Yeah.
I would say yeah. I mean, that's human nature, point. Right? I mean, that's human nature. Unless they purposely are strategizing, saying, well, let's put the easiest question at the end to reward those people who know how important it is to skip hard questions until you get to the end. Then you get rewarded with an easy question, because the people who are taking the test and get just not skipping hard questions, they will miss the easiest question at the end. So who knows what they do? We don't know what strategies they use in terms of making the test. But if the question is too easy, like it would have been if they literally said y is equal to 1/3 x, you can question yourself. But Seth, you misread the question.
I noticed they of course gave a distractor.
Well,
they gave a distractor for that misinterpretation.
Of course. Seth you could see Seth really feels humbled and humiliated today.
Yes, I am.
That is part of math.
But that's part of math,
That's part of math. So why don't we, with any further ado, let's clear the drawings, and let's see how they do it. Be interesting to see if they mention the negatives. If they say, hey, there's some people out there who are gonna get it wrong, like Seth. But they probably won't. Okay. So let's see. Show us step. We got it. Way to go. Step-by-step solution. Okay, here we go. And this one, let's make it bigger for everyone. Hold on. Oh, okay. Okay. This equation can be transformed into slope-intercept form. I wish they would say what slope-intercept form was. Y is equal to mx plus b. As follows. You basically solve for y. They show all the steps, which is very nice. They do that. The y-intercept does not appear, so it must be 0. Okay. A y-intercept 0 means the line passes through the origin. Fine. We can find another point. What? We can find another point that the line passes through the substitute non-zero value. So they're using a table. What they're doing is they're using the super initial approach
Yeah.
of
Yeah.
y is equal to negative 3x. They use a table. So they
Yeah.
make x be 1, y is negative 3. So then you're looking at a graph that goes through 0, 0, and 1, negative 3. They're not using slope.
Well, yeah, that's a waste. It's a waste. It's a waste because they called your attention to slope intercept. Right. And then they what they did was calculate the slope, and then they completely forgot about using the slope concept to solve the problem. What they did was then they took a different approach to determine the rest of the curve by fitting another point.
Right.
Well, which makes sense mathematically, but it is more efficient and displays more understanding that once you're thinking about slopes, you use your thinking about slopes to recognize that the slope is -3, and then look at the curves, look at the lines, and then immediately pick the one with a -3 slope.
Right. Yeah. I mean, this is a little historical thing. When you start learning algebra in 8th or 9th grade, even early 7th grade, the way you learn to graph is you do it this way. You get 2 points, or you make a table. No, you make a table. You make x, y, make x be 0, make x be 1. This is 0, this is -3. You graph 2 points, you connect the dots, and you get it. But then fairly soon afterwards, you realize that you're spending 20 years of your homework, 20 years of your day, graphing things using a table. It's so inefficient. It's much more efficient when you learn how to use slope, to pick the slope off, understand the slope, pick off 1 point, and then just march up and down the graph. The other thing they're missing is the real importance and significance of slope. If you have a -3 slope, you have to make sure your graph slopes downward.
Negative slope means as you go to the right.
Right.
Negative slope means as you go to the right, the line slopes downward.
Right. Negative slope. Yeah. Now, a slope of 3 means a pretty steep slope. So
it means when you step over to the right a certain unit, you fall down by 3 times that amount of unit.
No, you're talking about negative. I'm talking about absolute value. I'm saying a slope of either 3 or -3 is a steep slope. It is a steep slope. The slope is
it's not the slope that you want to do your skateboard on,
or skiing. Yes, or walk. Yes,
no,
or mountain, or just walking down. Right. So
you simply cannot. You cannot walk on a
So this is very personally important to me because I know I make slope calculations wrong about 20% of the time. If given 2 points, I always make a mistake with the negative sign and the x and the y. So I always double check my slope by knowing that if it's negative, it's gotta go slope down like this. And if it's a big number, it's got to be steep. And if it's a small number, like a third, a number less than 1, it's got to be shallow. And that's a great way to check yourself. And they're missing all of that in the explanation.
Okay, yeah. Do they discuss the distractors in this explanation?
Yeah, they do.
Well, let's look at that.
Let's clear this thing. Yeah, they always do. We just never look at it.
Well, let's look at it to see if they call your attention to this blunder.
So we're talking about negative. Which one? We're talking about sloping a negative a third. So that would be C.
Yeah. The incorrect. The graph should have a slope of -3, not minus a third.
They should have said.
Yeah. So if they don't do, what they don't do is what we did, which says that. Which our advice is avoid, try to avoid mistaking.
Yeah.
x equals minus a third of y for y equals mx with wrongly m equals minus a third.
Right. You're right. They really should have said there, like I would said with Seth, and we agree. If you did this, you may have done what Seth did, right? You may have said, "Hey, if you did this, you may have made the big mistake Seth did."
That's the mistake I made. Yeah.
Yeah. It would have been. You're right. If we were writing it, that's what we would have done. We would have said, "Hey, this is probably not why you got it wrong. This is probably why you got it wrong because you made
okay.
This big
now mistake. There is there's an advantage to thinking about the lines in terms of slope rather than the table.
Right.
It's only by understanding the slope that you could understand that the curve with the equation y equals mx plus b is a line.
Okay.
By simply paying attention, by simply thinking about the table, there's no way to predict what the points you didn't plot are.
That's true. Yeah.
But when you think of it in terms of slope, you realize that a straight line is determined by one of the points on the line together with the slope of the whole line. What makes the line straight is that its slope is the same everywhere.
Wait. What makes the line straight is that it's a linear equation. What makes the line straight?
No, so what?
No.
So linear, the geometric meaning of a linear equation is that the slope is constant.
Okay, we're talking
the same everywhere.
We're talking semantic, but people.
Linear means, the thing is, how do you relate geometry? Linear means the equation has this form.
Yeah.
It's all algebra. How could you talk about geometry simply from that formula? Other than a tautology.
Right. Well, something right now we're talking
linear, you could say straight line means linear.
Okay, look.
Linear means straight line. There's no content to saying that. But what there is content is that everywhere on the line, everywhere, the slope is the same.
Yeah. Okay, maybe we'll just let's take a quick break for introduction because we have to explain where Seth's coming from.
Okay.
Seth is a PhD in math from MIT. He's Professor Emeritus Computer Science at University of Albany. I am only a PhD in mechanical engineering, not a PhD in math. So I take things from a practical approach. Okay, so that's why Seth is going nuts here on the theory. Yeah, but y is equal to mx squared. Well, the squared, this x squared, this is not linear. The slope doesn't apply. I mean,
it has with what we learn in calculus.
Yeah, but nobody
and when you draw the curve, that's a parabola curve.
Seth.
And then when you draw the curve, at different points, what might be the slope? It's slow. It's not very slopey here. Let me draw a better parabola.
Seth.
It has no slope, zero slope here.
Right.
Here the slope is positive, and here the slope is negative.
Right. The slope changes.
Whatever the slope might be, it varies.
Right.
It is curvy.
Right.
Curvy. A straight line means. It means the slope is the same everywhere.
Right. But from the point of view of many people at the level they're doing this, I think it's simply strong enough and good enough just to know that if you have this type of equation, you know that it's a line. It's a linear equation. Linear equations, you're right, it's a tautology. Linear equations are graphed as a line. It's probably good enough just to know that. And therefore, when you recognize that this is a linear equation, once you solve for y is equal to negative 3x, linear, it's in the form of y equals mx plus b, you know that it's a line, rather than knowing all the theoretical stuff that's said, which is completely correct.
Well, I object. Theoretical actually means what it means.
Yes, yes.
So the opposite of theoretical is knowledge by rote or rule.
Yeah, which is generally very bad.
No, well, it's I would say generally very bad. It's faster to use.
Yeah, okay.
It's actually generally the kind of knowledge that people use most of the time.
Right. Okay.
And when that knowledge is accurate, it's very useful.
Right.
It enables you to use knowledge without the overload of thinking about what it means when you don't need to.
Fine. So you just made my point.
I made your point, but complete knowledge mixes and has both the fluency to use the knowledge by rule when that is appropriate, and also to expand out and think about the meaning when the meaning is appropriate. And then when you know the meaning and the rules together, you have the most power to solve SAT math questions quickly and accurately.
You are so right. You are so right. The complete knowledge involves both fluency in just knowing stuff and also in really understanding where it comes from. Right. Yeah. And you'll find that those people who take calculus and higher math, this further understanding will blossom like trees and flowers and all sorts of stuff. It greatly grows when you take more and more math.
So in this problem, the understanding knowledge about the slope called m and the geometric interpretation, how slopey the line is, all these different slopes, and recognizing that for negative m, the shape of the line is somehow going downward.
Yeah.
As you go from left to right.
Right. Yeah. But now
m is less than 0. And then the other thing is when the absolute value is greater than 1, then the magnitude of slopiness is high.
Right.
It's more towards the vertical than the horizontal.
Right. Okay, I think we're done because we're starting to go in circles.
Enough of this.
We're going in circles, which is ironic.
Leave you in peace.
We are in linear, not circles. Okay, everyone, have a great day then. All right, please like us, dislike us, give us comments on our YouTube videos. We use the feedback is very important to us. And if you have any SAT math questions, email them to us at satmathquestionoftheday@gmail.com. Everyone, have a great day.